Let's go to 7a. The line L is parallel to vector this. Find the gradient of the line L. The gradient, which means the slope. Since this line is parallel to vector, which means the direction vector will be 3, 2. That is x, y. So the slope equals y over x, that's 2 over 3. For 7b, the line passes through the point 9, 4. Find the equation of line in the form y equals ax plus b form. Since we already got the slope and given the point, we got to use y minus y1 equals slope x minus x1 form. So we plug in this formula, y minus, this is your x1, y1, 4 equals 2 over 3, x minus 9. First of all, we need to get rid of this denominator, so we multiply by 3. We don't want to deal with any fraction. Therefore, distributive property 3y minus 12 equals, this is gone. Only 2 do distributive property, 2x minus 18. Since I'm looking for y equals format, so I add 12 both sides. You get the 3y equals 2x minus 6. Then you divide it by 3. You will get the y equals 2 over 3x minus 2. Then they said write down a vector equation for the line L. We use R equals A plus T times B. You are given the coordinate on the line that's 9, 4. So we use 9, 4 plus T times the direction vector given 3, 2. This will be the vector equation. Let's go to number 8. Line L1 has equation this, vector equation. Line 2 has the equation like this. Line L1 and L2 intersect at point A. Find the coordinates of A. When you find the coordinate of the intersection, we will set up these two equations equal to each other. Therefore, you will set up 10, 6, negative 1 plus s 2, negative 5, negative 2 equals 2, 1, negative 3 plus t times 3, 5, 2. Check the first row. You will get 10 plus 2s equals 2 plus 3t. Second row, 6 plus negative 5s equals 1 plus 5t. Negative 1 minus 2s equals negative 3 plus 2t. First, we need to organize. Change each equation into ax plus by equals c format. Move this one over here. You will get 2s minus 3t equals 2 minus 10, that's negative 8. For second equation, I will move 5t here. So you have negative 5s minus 5t equals negative 5. For third equation, you will get negative 2s minus 2t equals negative 2. You could say these two are the same. Therefore, just choose the first two to solve. These two to solve. Let's organize. 2s minus 3t equals negative 8. For the second equation, I divide by negative 5 everything. You will get the s plus t equals 1. You can use substitution to solve, or you can do the multiplication. I multiply by 3 for second one. The reason why I do that is I can make the opposite variable here. So I can get the 5s equals negative 8, this is 3, plus 3 is negative 5, s equals negative 1. As long as you get one solution to any variable, that's enough. So you need to plug s equals negative 1 into the equation. That is this one. This s equals negative 1. So we plug in here. You will get this. 10 minus 2. 6 plus 5. Negative 1 plus 2. Your answer will be 8, 11, and 1. Let's go to 9a. Let vector u equals this. Vector v equals this. We do the dot product of u and v. And get the magnitude of u and magnitude of v. So we have 6, 3, 6 multiplied by 2, 2, 1. You will get the 12 plus 6 plus 6 equals 24. The magnitude of u equals 6 squared plus 3 squared plus 6 squared. You will get square root of 81 means 9. Magnitude of v equals square root 2 squared plus 2 squared plus 1 squared equals square root of 9 equals 3. Now we are looking for the angle between u and v. So for cosine theta equals u times v. The magnitude of u times the magnitude of v. We just need to plug in because we already figured out here 24. 9 times 3. You get the 24 over 27. Reduce, you will get the 8 over 9. Put into calculator, theta equals 27.3 degrees. Now let's go to 10a. Distances in this question are in meters. Ryan and Jack have model airplanes which take off from level ground. Jack's airplane takes off after Ryan's. The position of Ryan's airplane t seconds after it takes off is given by this equation. Find the speed of Ryan's airplane. We need to figure out the direction vector that will be velocity. Velocity equals this one. Negative 4 to 4. Therefore, the speed, which means the magnitude of this velocity equals negative 4 squared plus 4 squared plus 2 squared. You will get 6. For 10b, find the height of Ryan's airplane after 2 seconds. We need to plug in t equals 2. Therefore, the position, you will get x, y, z. 560 plus 2 times -424. You work this out, you will get 5 minus 8 is -3. 6 plus 4 is 10. 0 plus 8 is 8. For 3-dimension vectors, we know this is x, here is y. The height will be z. Therefore, they ask you the height. X, Y, Z, Z equals 8 meters. For 10C, the position of Jack's airplane 8 seconds after it takes off is given by this equation. Show that the paths of the airplanes are perpendicular. When you prove two vectors are perpendicular each other, we just need to figure out the dot product of two vectors. We need a direction vector for both lines. We know this is a direction vector, this is a direction vector. So we figure out the dot product. You have a -4, 2, 4. Multiplied by 4, -6, 7. You will get -16 plus 2 times -6 is -12 plus 4 times 7 is 28. You could say 0. So it is a perpendicular. For 10D, the two airplanes collide at the point this. How long after Ryan's airplane takes off does Jack's airplane takes off? According to the given information, this point on the both line. So let's go to the Jack's first. You will set up -23, 20, 28 equals -39, 44, 0 plus s. Here is a 4, -6, 7. You can use the first row to set up this equation so that you can figure out this s. That is -23 equals -39 plus 4s. Add 39 both sides. You could say this will be 16 equals 4s. So s equals 4. Now I plug into this vector equation. That is -23, 20, 28 equals 560 plus t times the -4, 2, 4. We just use the first row to set up this equation so that we can solve for this t. You will get -23 equals 5 minus 4t. After you solve, say you subtract 5, both sides, you get -28 equals -4t. So t equals 7. We know t equals 7 and s equals 4. Therefore, how long? It will be 3 seconds. Let's go to 11a. Consider the point A and a B and a C. Find AB. Since this is a coordinate, we got to use easy, which means ending minus starting. So I have AB equals B, that's 6, 5, 3 minus A, 5, 2, 1. So you will get 1, 3, 2. Find AC. Still, we need to do ending minus starting. So we have 7, 6, A plus 1 minus A, that's 5, 2, 1. So you have 2, 4, and A. Let Q be the angle between AB and AC. Find the value of A for which Q equals pi over 2. Pi over 2 means 90 degrees. Therefore, the dot product AB times AC equal to 0. So we have 132 times 24A equal to 0. Multiplication of corresponding component, you have 2 plus 12 plus 2A equal to 0. A equals -7. Now let's go to 11C. Show that cosine Q equals this. Cosine Q equals AB times AC. And then it's for AB, AC, the magnitude. So we plug in, you will get 2 plus 12 plus 2A. For the magnitude of AB, you could see that I get from here 1 square plus 3 square plus 2 square times square root. I will get the magnitude of AC. That is 2 square plus 4 square plus A square. Organize top, you will get the 2A plus 14. Look at the bottom. You will get 1 plus 9 plus 4. That will be square root of 14 times square root. 2 square, that's 4. 4 square, that's 16. So you have 20 plus A square. When you prove something, you always check what's going on here. That's we need to multiply by these two square root. So I have 2A plus 14. 14 times 20, that's 280. 14 times A squared, that will be 14A squared plus 280. That's you finish proving. For second one, hence find the value of A for which Q equals 1.2. 1.2, that's the reading. So we will set up cosine 1.2 equals 2A plus 14 square root 14A squared plus 280. You got to use equation solver to get the answer. So put the y1 equals cosine 1.2 minus 2A plus 14 square root 14A squared plus 280. When you plug into the calculator, make sure A change into X. Then you got to use the equation solver. You will get the answer A equals negative 3.25. Let's go to 12a. The following diagram shows the cuboid rectangular solid O, A, B, C, D, E, F, G, where O is the origin and OA equals 4i, OC equals 3g, OD equals 2k. Find the OB. So OB equals, we try to find a road from O to B, but try to use OA, OC, and OD. We have OA, go to AB. We know the AB equals OC. Therefore, we could see the OB equals OA plus AB. And OA, that is 4i. We do the 4, 0, 0. AB, that's OC. So we get 0, 3, 0. So we get 4, 3, 0. Or you can write down 4i plus 3g. Now let's go to OF. This is OF. Get a road from O to F. We do OA, then it's AE, then it's EF. AE, that's equals OD, and EF basically equals AB equals OC. So basically, I have OF equals OA plus AE plus EF equals OA plus OD plus OC. Therefore, I just need to add all this together. You will get 4, 3, 2. Or you can write down 4i plus 3g plus 2k. Now let's go to 3. Show that AG equals negative 4i plus 3g plus 2k. So let's draw the AG first. AG is here. I will get from A to O first. Then from O, I go to C. From C, I go to this G. So we write down AO plus OC plus CG. For AO, that's a negative OA plus OC, we already know, plus CG, that will be equal to OD. Therefore, negative OA, that's negative 4i. OC, that means 3g. Plus OD means 2k. That's it. Now write down a vector equation for the line OF. we know the line for OF, we need R equals to A plus T times B. That is a vector equation. For A part, we know that is 3, 0 plus T times. This is a direction vector. We got the OF, that is 4, 3, 2. Therefore, for the equation will be R equals T times 4, 3, 2. Now let's go to second one, the line AG. For AG, we still need like A and a T times B. So direction vector. Direction vector is given over here. So what's the A will be? That's the position vector, means the point on the line. So we can use A. A, that will be 4, 0, 0 plus T times direction vector, that is negative 4, 3, 2. For 12C, find the obtuse angle between the lines OF and AG. OF and AG. When you're looking for the angle between two lines, remember we need a direction vector. Direction vector for line OF, that is 4, 3, 2. Direction vector for AG, that is negative 4, 3, 2. Therefore, cosine theta equals 4, 3, 2 times negative 4, 3, 2. Then you have square root 4 square plus 3 square plus 2 square times square root negative 4 square plus 3 square, then plus 2 square. We work this out. You will get the corresponding component multiply. So we have negative 16 plus 9 plus 4. You will get negative 3. Denominator, you will get square root of 29 times square root of 29. Therefore, you got 29. For the theta equals inverse cosine of negative 3 over 29 equals, you will get a 95.9 degree.